Hello, everyone, and welcome to today's Tech Talk on pressure independent valves. My name is Sherry Adams, and I'll be moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of the desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use the control panel to submit questions. We'll be gathering your questions throughout the presentation, and we'll leave a little time at the end for Q&A. If your presentation is related to a particular slide, please include the number of that slide in your presentation. A PDF of the slides from this presentation will be sent electronically to all those who have registered for today's Tech Talk. We will also be recording this Tech Talk, and it will be available on our website under the resource section. The new password to access this Tech Talk is TechTalks18. Today's Tech Talk is brought to you by the Southwest chapter of the BCA. So I will hand this over to Joe Ellison, board member of the Southwest chapter, who will introduce our speaker. Joe?
Yes, once again, thank you for joining our Tech Talk to learn about pressure-independent valves, including their application and how they can be commissioned. Today's presentation is conducted by Ken Neckvisill with ATS Rocky Mountain. Ken has been in the industry for over 30 years, and he has extensive experience in HVAC systems and applying building automation controls. In his career, he spent time in both operations and sales, and he's currently serving as the sales manager for ATS Rocky Mountain. And without further ado, I will turn it over to Ken.
Excellent. Thank you, Joe and Sherry. I appreciate you, everyone, taking the time to jump online here and go through the presentation. Wanted to let you know I am on the control side of the business, so in the presentation it might have a little bit of a controls bent to it, but tried to make it as agnostic as possible. So with that, we'll jump in here. So on the agenda for the presentation is talking a little bit about what the actual working elements of the PI valve is. Then we're going to get into the benefits and kind of tying into that, and this does what. And we're going to talk about different pieces of what it does for an individual coil for a system, what it does to the equipment efficiency. So there's a lot of stuff that the benefits of a PI valve brings to a project. And then right towards the end, we're going to talk about the commissioning requirements for the PI valves. It's a little bit different than the traditional balancing valve and control valve combination. So what is a PI, or pressure independent valve? So the PI, the pressure independent, means that the device is not really dependent on pressure for operational control. And this actually is a huge benefit in many ways. So what we're doing with the pressure independent valve, built into it is a pressure regulating or a flow regulating device. So rather than the traditional model where you've got a balancing valve upstream of the control valve, and then you set that balancing valve in an attempt to set a flow, and we'll talk about that, but it's built in. So now we have a single device rather than a balance valve and the control valve together. And that balancing piece regulates it as system pressure changes. As you know, most systems that are coming out today on the water side have pressure control in them rather than the old constant volume three-way valves throughout. So in the industry, there are three types of pressure independent valves currently. The first one was a mechanical valve, and it's all mechanical elements. It's got a spring built into it, and as the pressure increases, it adjusts the flow back so that you have even flow across the device. And within that device, you have a minimum required pressure. In most of the pressure independent valves out on the market, you're looking at minimum required pressure of about 3 to 5 pounds, depending on which manufacturer. Used to be a little bit higher when they first came out, but they're getting better and better at manufacturing these things, and they're getting less and less expensive. The next one, which is kind of interesting, that's come out here in the past 5 to 7 years, is pressure independent valve using GPM control. So what they actually have is an electronic flow sensor built into it. The nice thing about that is that you're not using a mechanical element that could have the potential for clogging. If you're doing filtration within the system and draining everything down, making sure that you don't have a lot of large elements, it's not a big problem. But going to the electronic and GPM control, there's nothing from a mechanical standpoint to get clogged up. And then the last one here within the last few years is delta T control. So essentially what you've got is not only a flow meter, but temperature sensors on the in and out side. Essentially, it's a control valve that's using a BTU meter for control. And there is also no minimum pressure required for both of the electronic devices. So if you take a look at this graph off to the side here in the lower right, you've got a couple of plot charts, and it's kind of really telling about what the pressure independent valves and also now the electronic pressure independent valves are doing within a system. So if you take a look, this is a 60-ton valve example. And on that lower side with the gray plot, it's showing you for control, you're on a typical system with that size of a valve, you're going to be consuming about 240 GPM. And if you see off to the left side on the chart, that's showing the delta T. And I'm pretty sure if you've been in this business for longer than a couple of years, you've experienced low delta T and the impact it has in your hot water systems and even more importantly on the chill water systems. So that bottom gray one is a traditional control valve. And if you move up into the orange category, that would be a mechanical pressure independent valve. And you go from 240 GPM for a typical control scenario down to 144 GPM for that pressure independent valve. So a huge reduction in flow. And then an even bigger reduction when you go to the delta T control. You've got a device that's controlling flow based on delta T, what you want it to deliver back from whatever load you're controlling. Typically a large air handler, the coil in that you want to return, in this example, a 12-degree delta. All right, so some of the benefits, moving on from just the valve side of things, is what can happen in the design of the water side system as it is. Rather than going with a little bit more complicated system, reverse return, to get nice even flow across the entire system, the pressure independent valve at the coils allows you to go to a direct return. And so it's a lot more simplified. It's lower cost from a material standpoint, lower cost from an installation standpoint, and it's easier to put in. The other side of having a pressure independent control scenario is the energy savings. So the pressure independent valves will stop the valve from over pumping, right? The flow is always right and you're not over pumping systems. And if we go back to that previous chart showing the typical 60-ton valve, you're overflowing by a tremendous amount, right? You should be in the 144 GPM range. Now you're at the 240. Well, the system was designed typically with maybe about a 10% safety factor. Well, in that scenario, we're wasting a lot more of our GPM capacity, and we're going to run short somewhere because you're going to run out of flow. Well, the pressure independent guarantees that each of the sections and each of the coils loads are getting the proper GPM. And in turn, that gives us higher delta T, which will reduce pumping, and it will also reduce additional compressorized chillers that you need to bring on if you're not getting that proper delta T. And also on hot water side, if you're not getting the proper delta T and you've got condensing boilers, right, you may not end up condensing. So now you've got a really expensive standard hot water boiler because your flows are not being properly managed. And the other thing from an energy savings standpoint is the whole system is dynamically balanced all the time. And then the third piece on the benefit side is lower balancing costs. I believe ASHRAE recommends at a minimum to go back when you're balancing each of these loads, the coils, is to go back a minimum of 3 times. Okay? With a pressure independent valve, as long as you are taking a look at the device, making sure it's in the right flow range, you don't have to go back and rebalance that, because that is a fixed device, fixed orifice, and it's designed to deliver that amount of flow. So you don't have to go back and rebalance all of those different pieces as we change the balance on all of the other devices. The more devices or more valves we have in a system, the more complicated it gets in trying to balance it, because then you got to come back and balance the other pieces. Okay. The other piece too is see this all the time. You might have a coil that's leaking on startup, and you might have one of the mechanical contractors going back and shutting off the system at the balancing valve, and perhaps the balancing valve didn't get marked properly. And okay, we fixed the leak and we turn it back on. Well, that valve had been balanced, and now when they turn it back, they might turn it wide open, and now we lose the balance on that device, and that also impacts all of the other surrounding valves. So, and then if you take a look here, going back on the energy savings side, interesting chart to take a look at on the lower right there is the dollars per ton hour relative to delta T. So when you take a look at a system that's either designed, say, around 10 or 12 degree delta T, when you're bringing it back, the dollars per ton hour, you're looking at 30 cents when you're properly controlling in the 10 to 12 degree. But when you start having delta T issues and not returning the proper delta T, you're essentially adding the additional pumping horsepower and a lot of times the compressor horsepower, and then it starts to go up into 0.45 and higher cent, or 45 cents per ton hour. So it's a huge impact to the system. Some other benefits is the correct valve selection. So one of the companies that we buy valves from, they've got a technical guy. Love him. I mean, he's actually an engineer you can talk to, which that's pretty hard to find these days. He made a comment the other day. He goes, yeah, there's 3 traditional methods to have a correct valve selection, and he's like, 2 are wrong and 1 is impossible to get to. So what's nice about the pressure independent valve, you're not using the different pressure drop methods trying to figure it out, CV or valve authority. You take a look at how much GPM does this coil need for my application, and then you pick the valve for that, and you've actually completely sized the valve properly. Okay. The other benefit is you have less valve wear. So in traditional model, right, you design a system and you set it up for flow at 100% throughout the entire system. Well, the problem is in variable flow systems, as these areas are not at 100%, right, because we're only there maybe 2 or 3% of the time in the life of the system, is now that balance that you've set up totally starts going screwy. And as we adjust that pressure in the system, okay, that flow through that coil, especially ones closer to the pump, that flow changes, and now you're delivering, if we're pumping more water through the coil, we're delivering more of a heat content, or taking away more heat content if it's a chill water coil. And now that control valve needs to adapt to that and close down. Whereas in a pressure independent, we're adjusting and compensating for that pressure and delivering the same GPM depending on the position of that control valve. So now it doesn't have to compensate for the varying flows, because it is getting a consistent flow through there. All it has to worry about from a control loop standpoint is what the space is doing from a temperature control. And then the last one is better zone control. And you'll see this all over the place, that most of the systems, when they're closer to the pump, is you're going to have a lot better chance of having a controlled system. The hot water coils and chill water coils that are end of the pumping runs end up a lot of times with low flow, because all of those preceding coils are are sucking up all of the extra GPM, and so then you're ending up starving all of the end runs. Okay? So with having the pressure independent, it's delivering the proper GPM and stopping at that max point, so you're not over pumping, which allows the system to deliver full flow to those end piping runs. All right, so the pros. So with the pressure independent valve, it's going to maintain 100% valve authority, right? That device is providing a constant differential pressure across that valve, whether it's 10% open or 100% open, and that's giving you accurate flow. We talked about how it stabilizes the loop controls, right? It's not looking at two different elements trying to adjust that loop. From us dumb control guys, I mean, we have a hard enough time balancing or tuning a loop with just taking a look at one element, say the room temperature. Now, if we have to start trying to control it with the GPM constantly changing when the main pump is changing, that makes it hard enough. Improves system efficiency, right? Well, the biggest thing is that we're reducing the amount of flow that we're putting into the system because we are not ending up over pumping the system. Lowers system energy costs. That's, we're not bringing on as much pump or ramping up the pump high enough. And worst case, we're starting to add additional chillers or additional boilers to maintain the system because of a low delta T. Okay? It replaces the balancing and temperature control valve. It's nice not to have additional points of potential leakage. It also reduces the amount of labor required in the field. I have one device that acts as the balancing element and the temperature control valve. Another one for the commissioning side of things is you can commission in lots, okay? Not balance and commission the entire system, right? If I balance a little system that's got 3 valves, those things are balanced. I don't need to come back and worry about rebalancing those items. I can move on to another group of control valves and make sure that they're set and getting the proper GPM, and then move on to the next, right? I don't have to keep coming back, like per the ASHRAE standard, touching that balance valve 3 times and making it work properly. All right, so let's talk about some of the cons. One of the big drawbacks with the pressure independent valves is the additional cost, right? There's a lot more going on within that device. You got a lot more pieces, more complex design, more complex to manufacture. A few years ago, that really be the case. Now we're starting to see a lot of manufacturers refining designs and bringing that cost point down. In fact, in some situations, we're actually seeing that when you eliminate the labor and the balance valve, that a couple of the smaller pressure independent zone valves are actually less expensive than doing it the traditional method. Now, the bigger valves haven't quite caught up there, but we're seeing on the low end, and that's where you see a lot of the valves, a lot of VAV boxes with reheat or a lot of 4-pipe fan coils. So that cost point is coming down. Some of the cons is having a minimum and maximum DP. You have to have 3 to 5 pounds delivered at the valve for it to operate properly. But in most cases, you're seeing that at all of the valves. So with the exception of a few valves in the system, you're going to see that pressure, minimum pressure at the valves. And then the other one, when the pressure independent valves first came out in the design, is there was a major concern about fouling, right? You don't have your typical characterized ball valve that opens up and small elements within the system. If we haven't flushed it out and cleaned it out, they just keep blowing by. In the older designs for the pressure independent valves, there's a lot smaller orifices that it was going through, and they were susceptible to little bits and pieces getting stuck in there and fouling, and then it would basically take away from that pressure independent control. Designs across the board with all of the different manufacturers have gotten a lot better. They've improved the orifice size so that some of those little bits and pieces left over from building the system go ahead and pass through. And then I'll talk about some of the things that you can do to flush the system on the design side to prevent that as well. So So the design considerations, make sure you add a drain point between the coil and the valve, and that's for the debris flushing, right? So before we start and open up the coil to the system stuff, do a little bit of drain, make sure that anything residual, bits of metal, rust, dirt, anything that might be in the system, is you flush that out before opening up the system to the coil and bringing back. Y strainer, of course, I mean, you should put that on any, even, you know, the traditional systems, but definitely for the pressure independent valves. On the coils, you should have PT ports on each side of the coil, and that's really to measure what's going on with the valve, not necessarily to measure the flow through the pressure independent valve. And another one is recommend a third port after the PI valve, and that's to actually do it for the balancing side and commissioning side to measure pressure drop across the coil, because you do a different method of measuring and balancing the valve with the PI valve than you do with the traditional, okay? And again, the verifying the pressure independent valve is in the pressure operating range, not to measure flow. So one of the things when you go through to check and make sure on the commissioning side is, do I have that minimum pressure at my valve? And then if I verify my pressure independent valve is the right range, as long as we have that minimum pressure, you know that valve is going to operate properly. All right, test and balance considerations. Okay? You must confirm the pump is providing the minimum pressure at the furthest valve. Nice thing about pressure independent, once you confirm that, okay, you don't have to go back. There's no readjusting the system pressure and going back. Let's say you're rebalancing everything and you've got an issue there, and now you've changed the pressure dynamics within the system. That doesn't come into play anymore on the test and balance side. Mechanical and then some electronic valves, we verify the flow by looking at the air delta T. Okay? You can take the coil, if you know the airflow across it, and then you measure the delta T, then that's one way to confirm flow. The water delta T, measuring it across the coil to confirm flow, or what is traditionally recommended to confirm flow, if you need to, is coil pressure drop. Okay, so the coils that we're running the flow through, you can go to the manufacturer and pick up their coil pressure drop charts, and based on the pressure drop that's going through the individual coil, we can determine the GPM that's flowing through it. The nice side about the electronic PI valves is there's no minimum pressure required for the electronic, whether it's GPM control or delta T control. All right, I want to show you kind of a diagram in regards to static balancing, which is the traditional method, balance valve and control valve scenario, where you go through, and in the traditional balancing, we go through and set up the system for 100% flow. And that's great, everything's balanced, and if we're flowing 100%, everything is going to operate probably fairly nicely. The problem is in the systems where we're doing variable flow, when we drop off that flow, now we're going to end up over pumping typically closer to the pump, and then towards the end of the loop, because we're backing off on that pump and we're reducing the amount of pressure, system pressure differential, okay, we're going to end up starving the coils that are at the end of the loop. With a pressure independent system, it is dynamically balanced. It's regardless of pressure, as long as that endpoint where you're controlling, right, your worst valve that you need to maintain that 3 PSI, as long as you have it there, the entire system dynamically rebalance, right? And every coil is always under control, and you're going to get the exact GPM, whether or not you're at 100% flow, or if you back off and dropping it down to, say, 20% of system flow. All right, so, and this does what? So better coil control. I had mentioned about having the two different elements, you know, the differential flow if our system is varying in flow, and then having to control to the space temperature, right? Well, because we're not adapting to a couple of different things going on, we just have to worry about one element, the space temperature that we're trying to control. We're going to have less wear and tear on the actuator. So the control valve portion of it is going to last a lot longer than in a traditional system. Okay? You're also going to have better coil control because it's sized based on the proper GPM. I had mentioned about my technical buddy that talked about the 3 different pressure drop methods of trying to size a control valve. Two or you'll never get right, and one is impossible. These are the ones, okay? In traditional methods, you have a flat CV spec, okay? Or most of the time we'll see, give us a pressure drop of 4 PSI for your control valve, and you're not taking a look at what the system is designed to do. And then another method is valve authority, which is about impossible to do and get a properly sized valve, okay? So with using the pressure independent, you size it based on the GPM so that when you're at 100%, you're delivering 100% of the GPM. When you're at 50% open, you're getting 50% of the GPM for the design, okay? You get better loop control. So we talked about the issues related to the 2 different items going on at the coil control that we're doing. Well, it also ties back and plays havoc with the main control loop with our pressure control in the system. So if we've got a valve that's fighting the pressure going up and the GPM changing, well, now that loop, it might get out of control until it finds itself. So it might be opening more than it should and then closing more than it should as it tries to find a satisfactory control point. Well, that changes the demand required for the control loop. And if you've got some improperly tuned valves out there, the traditional method is a whole lot harder to control, and then that will screw with the main loop. And so each of those coils are hydronically isolated from the system. So if that pump starts ramping up, adding more pressure, and let's say it's the coil that's closest to the pump, right? That pressure goes up, he's going to have the biggest impact, and it doesn't see an impact because it compensates for the higher pressure it sees at the coil, and so that coil is still seeing a consistent GPM based on the position of that control valve. Other system benefits, it reduces the delta T issues. Okay? Equipment is going to run absolutely more efficient when we're getting a higher delta T. Lower pumping costs, no overpumping. When I was researching some of this stuff, found typically you'll see a 16% savings by using pressure independent over traditional control on a system that has VFD control in it. Okay? Another side benefit is that it prevents underflow and overflow, right? When you've got a system that starts up in the morning, all of those system elements the valves are gonna open wide open, and in certain areas you're gonna have overflow and underflow throughout the system until it starts catching up and satisfying the system. With the pressure independent, we're getting the correct GPM and correct control throughout the entire system, so your system's gonna start up a little bit quicker in most areas. The balance side of systems, okay? The system will stay balanced. I don't know how many times I've watched on jobs when I was working on the field side of things that the balance valve would be used as a shutoff, and then it would never get put back. I don't know how many times I've seen out there where they know they've got a little bit of a load issue, and most of these field guys, they'll go in and just crank open the balance valve a little bit more than what it's designed for to satisfy the load, because we've never seen somebody, go in and put in a space heater. Well, the design engineer didn't account for that space heater. Now that's in there. Now it's got a bigger load. Maybe that cooling coil needs to compensate for that. Okay. Well, that happens to be in the president's office. So what is the maintenance guy going to do? Well, I'm going to crank up some water so I can make sure I satisfy the president's office. Well, now in the traditional method, he screwed up all of the balancing in that near area to satisfy that zone. Okay. Well, when you shut off the pressure independent valve, the balance side is built into the valve, so when they open it back up, that thing's going to go right back to being balanced and not impact the surrounding systems. Okay? Again, we mentioned about having to go back and rebalance existing systems if you're adjusting that. You don't have to do that with pressure independent. Okay? And then you don't have to balance in the traditional method, just confirm that you've got the proper delta T and flow across the coil that you're controlling. All right, and then for you folks, simplified commissioning, okay? You can commission by smaller systems as you go through because you know that as long as the device is set for the proper GPM for whatever you're putting it against, and you've got the minimum pressure, inlet pressure, that device is going to deliver the proper GPM. It's not going to underperform and it's not going to overperform, okay? Talked about measuring flow to confirm. Well, now we're not measuring flow across the traditional balance valve. We're going to measure it across, well, typically it's measured across the coil to confirm flow. A lot of times once you start doing and confirming those flows and know that, that you're set, there's a lot more assurance that everything is more balanced than in the traditional method going and balancing across the a balancing valve, okay? The other thing is not having to worry about all of the calculations and going through as in the traditional balance valve, seeing what pressure dropped, going to the chart, making sure that everything's set. It's a little bit easier on the commissioning side of things. All right, with that, I will open it up to questions.
Thanks, Ken. Doesn't look like we have any at this moment. We could give it a second here to see if there's anybody that wants to type in a question really quick. Okay. And we do have a question. See, I knew it would only take a moment. Is the minimum pressure required a DP across the valve or just upstream static?
Upstream of the valve.
Okay. Any other questions? Okay, we have another one. Based on your presentation, there doesn't seem to be a reason not to do pressure independent valves. So why isn't this the new standard?
I think partially, well, most jobs are always over budget, so they're always looking for ways to save money. Personally, I'd like to make the argument that in the end run, with all of the issues that you have to deal with and all the problems, that it ends up being more costly not to go to pressure independent. You're absolutely right. In my mind, you should always use pressure independent control valves. It makes life a lot easier, not only on the startup side, but in the life of the system.
Okay, we do have another question. Based on only needing upstream pressure, what is the benefit of having DP across the valve?
I guess maybe I don't understand the question. I mean, you've got to have a minimum pressure delivered to the valve for it to be able to operate. And then, you know, if the pressure goes up, the internal compensating device, usually a spring assembly, readjusts it so that it maintains a consistent flow or a consistent pressure drop, right? Because it's an orifice device, and it will adjust and compensate so that it's delivering consistent flow based on position.
Okay, and it looks like we have another one here. If pressure independent valves are less costly in the long run, is there a rule of thumb for how long the payback is for spending the extra money up front?
No, there's really not that I know of. Several of the pressure independent valve manufacturers do have some spreadsheets and computer programs that can help assist in taking a look at what cost reduction, but it really depends on the different systems and what you have in there. But I do know that, you know, there are a couple of different manufacturers that have created some tools to be able to do the analysis.
Great. Well, thank you, Ken. And I think that's all the questions that we have at this time. So we really appreciate your time and expertise. And on behalf of the BCA, we'd like to thank everyone for participating in today's Tech Talk. Have a great.
Awesome. Thank you for having me. I appreciate it.
Absolutely. Thanks, Ken. Thanks, Joe.
Thank you.
Bye-bye, all.
Bye-bye.